Hi everyone, my name is Nick. I am CCIE in routing and switching. My YouTube channel is about networking technologies, and right now most of my videos are in Russian. This is my initial attempt to record a video for international audience, so please go easy on me. In this video we will talk about Cisco ACI, so let's get started. Here is our agenda. I will explain what ACI is, why do you want to replace your current DC networking with ACI, what are ACI components, and how ACI architecture looks like. So, what is Cisco ACI? ACI stands for Application-Centric Infrastructure. It is Cisco's SDN solution for data centers. And please do not confuse it with ACI EM, where EM stands for Enterprise Module. It is a different product with different purpose. Our topic today is just ACI. And as I mentioned before, ACI is solution for data centers, so you should plug in servers into it, not PCs, not IP phones or anything else that is clearly belongs to campus networking. Key features of ACI are automation, focus on applications, huge integration capabilities, for example, integration with virtualization platforms such as VMware, vSphere, or Microsoft Hyper-V, for example. Integration with container networking, for example, Kubernetes. Integration with orchestration tools such as Cisco Cloud Center, integration with public cloud networking, and many more. And of course, ACI has pure networking benefit if you compare it with other DC solutions. Example of pure networking benefit, in my opinion, is VXLAN, which is used by ACI, versus old technology such as Fabric Path. And let's talk about why you should want to replace your current gear with ACI. At first place, ACI simplifies data center networking and hides a lot of complexity from administrator. ACI uses VXLAN behind the scenes, and if you configured VXLAN before on standalone Nexus switches, probably you will agree with me that it is not very simple configuration. ACI hides that complexity from you and even more. You don't have to configure each switch in your fabric separately. In ACI you configure all fabric as a whole. So for example, if you take your classical Nexus 5K switches and Nexus 7K switches, for example, and you want to configure VXLAN inside your fabric, and you do not have any automation software, you will have to deal with each switch separately. You can use CLI or REST API, but the main goal is that you will have to configure each of your switches inside your fabric separately. It is not the case for ACI. For ACI you will configure all your fabric as a whole. You will use cluster of API controllers, which allows you to configure your fabric as a whole, not to configure each switch in your fabric separately. And it points us to next bullet, which is automation. ACI has REST API, so its automation capabilities are much more better than, for example, CLI scraping, which is still used since it is the only way to deal with old platforms. Next benefit of ACI is its integration capabilities, which are huge. You can integrate ACI with your VMware infrastructure, Hyper-V virtualization, OpenStack, container networking, orchestration tools, and much more. From my point of view, the main goal of all this integration is to achieve rapid provisioning of network infrastructure for end applications. And here we come to application-oriented nature of ACI. When you use ACI, you begin to think more about applications and much more less about classical networking elements such as VLANs, subnets, trunks, routing, whatever. And it definitely has logic, since at the very end we use all our fancy networking stuff just for one reason: provide application to the customer. Next, let's discuss pure networking advantages of ACI. First advantage is leaf-spine-leaf or close topology. Let's draw it really quick. In leaf-spine-leaf topology, we have two layers of hierarchy. We have spine layer and leaf layer. It is pretty simple and scalable topology. So if you want to add more leaves to connect to your servers, you just need to connect it to your spines. If you run out of ports on your spines, you just add a new spine and connect all your leaves to it. We will talk more about this topology later. And of course, one more benefit of this topology is that any host inside your fabric has to traverse maximum of 3 hops to reach any other host. So for example, we have server 1 sitting here and server 2 sitting here. If server 1 wants to talk to server 2, it will go to leaf 1, then to spine 1, for example, leaf 3, and server 2. So at the worst case, server 1 will have to traverse 1, 2, 3 hops to reach its destination, server 2. Of course, if you have, for example, server 3 connected to the same leaf and server 1 wants to talk to server 3, it will traverse only single hop, which is leaf 1. Let's go further. Next advantage is Ecmp, which stands for equal cost multipathing. ACI allows for true active-active Ecmp, which is achieved by routing Ethernet frames. I told you before that if server 1 wants to talk to server 2, it will traverse leaf 1, spine 1, and leaf 3. It is not all the truth. Actually, since ACI is capable of doing Ecmp, when server 1 talks to server 2, it can go that way, leaf 1, spine 1, leaf 3. It can go leaf 1, spine 2, leaf 3, and it can go leaf 1, spine 3, leaf 3. So it's truly active Ecmp. Let's clear that stuff and go to east-west traffic optimization. ACI uses Anycast gateway on each leaf. So let's draw it again. And let's imagine that we have two servers which are connected to the same leaf. Server 1 and server 2. And let's imagine that server 1 has an IP 10.10.10.10/24 and server 2 has IP 10.10.20.10.24. So as you can see, these servers belong to different subnets, so they need a default gateway. To talk to each other, since they reside on different subnets. In case of ACI, default gateway for that network and that network will reside on leaf 1, leaf 2, and if you have many and you have more leaves, you will have that default gateway on all your leaves. So when server 1 wants to talk to server 2, it has to traverse only leaf 1. Routing will be happened here on leaf 1. And if you really care about security, ACI can help with that as well, with micro-segmentation capabilities and whitelist policy, which is implemented by default. So let's clear it again and talk about different case. What if you have server 1 and server 2 on the same subnet? And you want to implement any networking policy between them. For example, ACL. In traditional networking, of course, it is possible. You can put firewall in transparent mode between them. But in ACI, it's much more easier. In ACI, you have micro-segmentation capabilities. So basically, you can attach ACL between hosts on the same subnet. In ACI, it is called contract, and we will talk about it later. And as I mentioned before, ACI implements whitelist policy by default. In ACI, you have Epg Objects, which stands for endpoint group. If you have some objects inside Epg1 and you have different objects, different servers, different VMs inside Epg2, they cannot talk to each other by default. If you want Epg1 to be able to talk to Epg2, you will need to define that access explicitly. Next, let's discuss ACI physical components. ACI consists of two main components: switches and controllers. What about switches? ACI uses Nexus 9K switches, 9K series. Switches are divided into two roles: leaves and spines. As far as I know, there is no model which can be a spine or a leaf, so every physical box model is tied to a specific fabric role. It is a spine or a leaf. And of course, one box cannot be a spine and a leaf at the same time. So if you want to build your ACI fabric, you will buy some switches, and every switch in your fabric will have only one role. And as I mentioned before, it depends on switch physical model. So of course it also depends on your data center design, and of course you have, for example, top of rack switches, which usually has much more or less port density than spine switches, which usually have a lot of ports, and that ports have very huge bandwidth. 40 gig Ethernet, or for example 100 gig Ethernet. Also, most of Nexus 9K switches have two modes of operation. It is ACI mode for ACI, of course, and an XAS mode for standalone usage. So you can buy Nexus 9K switch and use it with an XOS mode as standalone switch, which is not part of ACI fabric. It is possible, but I believe that there are one or two models which supports only ACI mode. Second component is APIC controller. APIC stands for Application Policy Infrastructure Controller. It is the brain of entire ACI system and should be deployed in high availability fashion with 3 or more controllers, which forms the APIC cluster. Physically, controller is a Cisco UCS C-Series server. You can choose between different capacities for different fabric size. Of course, if you have such a little fabric, you don't have to buy the most powerful UCS C server. But if you have a bigger fabric, you should consider buying more powerful servers for APIC cluster. Right now, the only way to build APIC controller cluster is UCS C-Series. So you cannot use UCS-B, for example. You cannot use non-Cisco hardware. you cannot use virtual machine, VM, or anything else. You have to buy UCS C server. And let's talk about our last topic today, ACI architecture. Here you can see our spines, spine 1 and spine 2, which form spine level. Here you can see leaf 1 and leaf 2, which form leaf level. Of course, you can have more spines and more leaves. Is just a simple and little example of ACI fabric. And you can see here Epg controller cluster, which consists of Epg 1, Epg 2 and Epg 3. And you can see that we have no connections between spines and no connections between leaves. Actually, it is ACI and spine-leaf topology rule. You must not have any connections between spine switches and between leaf switches. And the second rule is that all spine switches should have connections to all leaf switches, and vice versa. All leaf switches should have connections to all spine switches. So for example, we have spine 1 and it should have connection to all leaf switches, and it has to leaf 1 and leaf 2. And spine 2 should have connections to all leaf switches, to leaf 1 and leaf 2. And vice versa for leaves. Leaf 1 has connections to all spines, to spine 1 and spine 2. And leaf 2 has connections to all spines, to spine 1 and spine 2 in our example. Endpoint should be plugged only into leaf switches. So if you want to plug servers into your fabric, you will plug them into leaf switches. In 99% of cases, spine switches will have connections only to leaf switches, but there are some exceptions. But anyway, you will not plug your server into spine switches directly. It is not supported. That was a brief overview of Cisco ACI product. If you like my video, please put your thumb up and subscribe to my channel. Bye bye!